Okay, so this week, we're gonna be introducing chapter 5. Just the first half, it's a long chapter, and so we're looking at pages 99 through 142. So, it's a good chunk of reading, and so, my goal here is just to try and introduce, some things. I brought some tooling in to show you. I've got some videos, I've got a good mix of different things, and so I'm trying to add to the deck. That is not a direct replacement, right? You do need to make sure that you read through the chapters, do the key terms, and answer those chapter questions before our next Tuesday class. So here we go. So chapter 5 is all about stationary machines. We kind of up to this point, we kind of talked about portable machines last week, and so this week we're going to be talking about stationary machines. And one thing is true. In anytime in manufacturing, in anything where you're actually making something and using equipment to do that, there's always more than one way to do things, right? If you want to make a dado, you can use a table, you can use a router, you can even use a milling machine, right? There are always more than one way to do things. So how do you know? How do you know what to do? What are some of the different considerations that you guys need to think about? What do you think? Cost as well. If you don't have the machine and you're going to have to make a purchase, certainly, yeah, it doesn't make sense to just go to Lowe's or wherever you Acme Tools, there's a lot of tools. But if you go to the I want to buy it. You can't do it. Sometimes you have to make what you have to work. You said cost of your time, right? There's going to be setups that are going to be required. So how long does it take you to set it up, and what is that going to cost? So that's a good point. What else? What are you trying to decide? What is the best way to create a certain feature output? The end result. How well it turns out. Am I able to complete am I able to do what I want to do with the level of control and quality that I need? Okay, that spec out on it. Absolutely. Am I going to be putting anybody at risk if I try to do what I want to do? Right? And so those are all really good things. Okay. And some of them you could probably prioritize above another. And so that is kind of, those are kind of the main criteria that I think about, or the considerations that I think about. And at some point you got to make a decision. Oftentimes for me, I know I get paralysis by analysis. I just, I don't know. I'm always thinking, what is the best way to do it? Well, this is the advantage. At that point, you just have to make a decision and do it. And so, and quite frankly, it might mean doing it more than once. And so it's always good to kind of have a test piece to set it up and to try it, and just to make sure that it's going to be the way you want it. And the end product is the setup is going to produce the work that you want to do. So I think that's important, right? And I think a lot of value is going to come of kind of learning the overall, the different options. So that's really the value of kind of going through it and talking about each of these machines and what they're capable of, and talking about some different tooling that can be utilized with each one. So you can kind of understand what the potential is there, so that that'll help to better guide you as you're trying to figure out, solve problems and figure out how to make parts. Okay, because it is true that the plans don't always tell you what to do. You have to kind of figure out some of that on your own, or maybe the plans tell you what to do, but you have a different machine that they may not, or you can't always assume that what they say is the right way to do it. Okay, there's always more than one way to do it. Okay, so today we're going to introduce several, I guess, the joiner, the thickness planer, the table saw, and the bandsaw. So there's quite a bit here, so we'll get rocking and rolling. All right, so when a tree is felled, and first thing that happens is it's cut into lumber, they dry it, and then you buy it. Okay, that's kind of how we buy a lot of hardwood. which is as a rough sawn lumber that comes in random width and length and to a specific thickness, okay? But rough sawn lumber, sometimes it's kind of hard to know where to start because it's really rough. You don't have any straight edges. You don't have any flat surfaces. When they cut it up into the lumber, and then they dry it, everything, it twists, it frowns, it warps, And so where do you start? Okay. And that can be a challenge. And so there is kind of a tried and true process. And so what I usually do, first things first, is you need a straight edge and you need a flat surface. One thing you never want to do is try to run twisted board on table saw. That's just bad news. What's going to happen, you're going to get into that, and then it's going to want to rock, and now you're binding against the blade, and it's going to want to kick back, and it's just not a great idea. See, the first thing you got to do, and these are kind of interchangeable. One, and I guess I would start with getting a flat surface. So, and there's a couple of machines that you can use to get a flat surface, but we'll say joint. We're going to a flat surface. That's the first thing. Okay, so we're going to use the joiner. We're going to create a flat surface. Second thing we can do is then use the joiner, and we're going to get a straight and square edge. Okay. Once you have flat surface and a straight and square edge, now we can start to do some things. The options are open. We've got some options. Okay. At this point, what I would do, and we'll learn a little bit about the joiner here and some of the capabilities. Let's go ahead and finish this list here. But then I would go to the thickness planer. And I would plane or surface the second surface. By doing that, we get two surfaces. The first one is flat, and the second one will be parallel. And so we'll get two parallel surfaces, and that would be good. And then from there, we've got a straight edge, we can go to the table saw. We can rip another, we've got a straight edge, now we can rip another parallel and square. We're going to rip our second edge. Now we've got some stock that we can do some things with. Okay, because we've got four prepared edges. We've got two smooth and hopefully parallel surfaces. We've got two square and straight and hopefully parallel edges as well. Okay. And so once you get to this point, then you can start cutting, cross cutting into length, cross cutting board. And one of the things too, I'm just going to kind of preface this. I would start, again, this is rough sawn lumber. This got out of the kiln, it's been drying, it's got a lot of stress, especially on the end of the board. So it'd always be good to remove the end of the board. Never fails every semester. Obviously, I look at a project, and one of the parts will have a red. How they take the logs and they actually paint the end grain to help to kind of control it, keep it from drying out too quickly. And so that paint always makes it in one of the projects that I see. It should. Okay, you should always cut off the end of that board because that's a rough sawn end. It might not even be square. So cut off the end and then measure cut the other side. Those are kind of the main steps in order to kind of get you into get you into something that you can use and start preparing. Now you can start cutting curves, you can start treating edge, and you can start doing some other things and really taking your parts and bringing them to the final step that way. Okay. So as kind of an introduction to the joiner and the planer, because that's one of the first machines that we're going to need when we're grabbing stuff rough sawn lumber. Which, let me ask you a question, let me back up. And because this has happened to me a lot, right? I won't actually joint that first surface. Rather, I'll just use a planer. I'll go straight to the planer. What's good about that and what's not good about that? Yeah, so, and we'll kind of learn this a little bit too, when we go through, just kind of learning about the function of the planer. But if your board has a natural twist and you send it through the planer, is that twist going to come out? Not necessarily, because the way it's planer, if you've got a table, right? And you've got two pressure rollers, and you've got a cutter bed. Okay, as you push this forward, it's going to get pushed down with a lot of pressure by these pressure rollers. You hold it down against that table so that then your cutter bed, I'm kind of drawing, it's going to do a little bit. The board's going to be in there, and then the cutter head is going to take off maybe 16, 17 inches off the top surface. So if there is a twist, oftentimes this pressure roller is going to remove the twist. It's going to straighten it out. So just pushing it down against a flat table. And so that's why ideally you would start out with a joiner before going to a planer, because joiners don't work that way. Okay. The board is going to be in a relaxed position as you're removing material. How do we get around that? Well, you can use a double surface, a double-sided planer, and cut off both the top and bottom at the same time. If that helps. And that's probably the biggest reason why I buy my lumber already skin planed with a straight edge, so that the distributor can worry about a lot. Because that's kind of a heavy. And you got to have a lot of skill to do that. All right, so let's learn a little bit more about the joiner and the planer. I've got a video here, and so we're going to watch this. Pay attention to, as we watch this video, pay attention to how it works, function, and the differences. I missed it. Maybe the website changed a little bit. No, they don't have the video. So maybe I went right over it. Well, let's see. That was a good video. Where did it go? I guess that's the rest of the
My name is Aaron Massey, and welcome to Woodshop 101. The goal with this series is to help get you familiarized with some common woodworking tools and practices and help you expand your skills and knowledge as you build out and expand your workshop. On today's episode, we're going to look at the difference in uses for two common woodworking tools, the planer versus the jointer. Both of these tools carry a fairly hefty price tag, and many beginners or intermediate level woodworkers may not have either tool. But before you go and spend the money to buy one, it's important to know exactly what each tool is used for and how it works. Now, both of these are preparation tools, meaning that they are used at the beginning of a woodworking project to help you get flat, uniform wood to work with. If you're just starting out, you may be using whatever construction lumber you can get your hands on from the big box store, or you may be spending quite a bit of money on pre-milled hardwoods that you picked up from a local specialty store. In either case, the projects you work on are limited to material that you buy. These tools can help you create wood projects in any size or thickness that you want. Now, it's very rare that wood you purchase doesn't have some kind of warp or movement to it. For the sake of this video, I'm showing you 3 common types of wood warp you may encounter. Bowing is when a board has a bend in it so it doesn't lie flat. A twist is when the board won't sit flat on all 4 corners so that when you press on one corner, the board rocks back and forth. And cupping is when the board has a cupped shape where the sides are higher or lower than the inner part of the board. Depending on the piece of wood you're working with, it may have one or all of these attributes, and if any of them are severe, it can make working with the piece very challenging. Think of woodworking like cooking in the kitchen, and the wood is your ingredient. When you have quality ingredients, it's easy to create a quality finished meal without a lot of extra steps and things added on top. Woodworking is the exact same way. When you have nice, flat, and uniform lumber, it's much easier to create a quality finished product. And that is where a jointer and a planer come in. Now, a common misconception is that a planer makes the board flat, when in reality, a planer is only used to make a board uniform thickness. So first, let's take a look at how a planer works. If we were to remove the side of a planer and got a look at the inside, here's what we would see. We see 2 feed rollers. These rollers apply downward pressure onto the piece of wood so that it stays flat along the bottom of the planer, while at the same time feeding it through the planer itself. We'd also find our cutter head. Now, there's different cutter head types available, but they all do the same thing. It's a cylinder that spins at extremely high RPM and cuts the wood as it's fed through the machine. So let's take a look at how that works with a piece of wood. As you can see, the wood is fed through the machine. The roller head pressed down onto the piece of wood, pushing it down along the deck as the blades cut it to a uniform thickness. Now let's see what happens if we do this with a piece of wood that has a bow. As you can see, as the piece is fed through the machine, the roller is pressed down on the piece of wood and it follows the bow. So while you'll end up with a piece of wood that's uniform thickness, it won't be flat. If you put the piece over and feed it through the machine, the rollers will push down on the bow and flatten it out as it goes through the machine. But as it comes out the other side, the board will spring back to its original shape. So while your board will be uniform thickness, it still won't be flat. The same can mostly be said for a board with a twist in it. As the board is fed through the machine, while it may take a little bit of the twist out, the rollers will push down on the board and it will follow whatever the opposite face of the board is doing. As it comes out the other side of the machine, the board will be a uniform thickness, but it won't be flat. The one scenario where a planer can produce a flat surface is if the piece has a cupping. Depending on the severity of the cupping, you may be able to plane down enough of one side of the board to achieve a flat surface. However, you may have to feed it through the machine several times and lose a lot of material in order to do that. Once you have that flat surface, you can flip the board over and run it through the machine again and get a flat surface on both sides. But again, you may have to remove a lot of material to do this. So in order for a planer to work effectively, you have to have a flat surface on one side of your board in the first place, and that's where a jointer comes. So if we take a look at a jointer, you'll see we have 2 tabletops that are co-planar to each other. An in-feed table and an out-feed table. Now these tables are adjustable in height depending on the depth of the cut we want. And we'll also find a cutter head very similar to the cutter head that we have in the planer. Now if we feed that same bowed piece of wood over the jointer, you'll see that if we don't apply too much downward pressure on it, it'll take out that bow. It may take a few passes to do it, but what you'll see is that it creates a flat surface on the bottom of the board. However, it doesn't create a board that's a uniform thickness. So in order to create a board that is both flat and uniform thickness, that is why you have both a jointer and a planer. The jointer creates a flat surface for the depth of the planer to reference and create a board of uniform thickness. Well, I hope this video is helpful to you for understanding how a jointer and a planer work and why they are used for specific applications. This video just touches on the surface of what you.
Okay, I got that. I was really impressed with that. As a teaching tool, oftentimes it's hard to create those visuals as they're kind of talking about them. But so just by way of review, the planers will create will remove material and create a specific thickness. One other thing too that I've been told, and I think is true, is they create parallelism. Okay, so if you have one side that's flat, the other side will be parallel to that. So, that is also true. And so, anyway, we kind of saw how in that video, the joiner and its function and how it can be used to remove and basically take a non-flat surface and create a very flat edge or surface that way. A lot of joiners are actually, some of the benchtop models are gonna only have a cutter head that's about 6 inches wide. Some of the more industrial size machines are gonna go up to 8 or maybe even 10 inches, but they're not a super wide cutter head, like say, for example, a planer. Planers oftentimes, like our planer, has a 20-inch wide cutter head, so we can send a really wide board. And so that's kind of one of the challenges when you're trying to joint a surface. And so sometimes the joiner that you have will work. Sometimes you might have to use a portable joiner or a portable plane like this with a big gift. But I haven't had great luck using something like that. I think you have a little bit, probably more control using the axle to create a flat surface that way. So. But joiners are really nice. They've got, you can see that they've got a fence along the back side. And so that fence has a little bit of versatility. You can change the angle, and so you can create bevels on a joiner if you wanted to. But again, it always goes back to that initial question. What machine am I going to use? And what is the best machine to perform the job that I need to perform? There's going to be some setup here, and this may not be the best option. You might want to use a router with a chamfer bit. You might want to use a table saw by tilting the blade. And so there's always going to be more than one way to do things. I've never created a bevel on a board with a joiner, but you could if you wanted to. Okay, you can create rabbets. Again, I've never created a rabbet on a joiner for a rabbeted part using a joiner, but you could if you wanted to. I guess that's the point. You can also joint a taper. I have done this before, and I have found this to be a valuable skill, a valuable machine to create a taper. But you also have the taper jig on a table saw that you can use. Okay, or you can set up a fence, and you can use a skill saw and use a portable tool for making taper. So there's different ways of doing things. But yes, you could use a joiner to create a taper that way. So. One of the things I wanted to mention was the different types of cutter heads, and we kind of talked a little bit about that in the video. These are kind of the main two technologies that you're going to come from, and they are not created equal. I do have my preference. You have what's called your high-speed steel knives, and typically, depending on the style of jointer or planer, like I said, the similar cutter heads are used for both. You can buy the high-speed steel knives where you have one single blade that goes all along the width of the cutter head, and you have these little, they call them gibs. They're basically a bolt, and by turning those bolts, it basically creates pressure and holds that cutter head in place. And there's a little spring underneath of that. So once you loosen all these gibs, that cutter is kind of spring loaded until it'll pop out that way. And so you use a little tool, you get it set in there. One of the biggest challenges when you're resharpening the high-speed steel knives on these cutter heads is getting them set so that at a uniform height. And so there's a little tool that you can use. So that's a little bit beyond where I wanted to go. The ones I really like are these helical carbide insert cutter heads. These are just so nice, you guys, for a couple of reasons. One is you're using carbide tooling instead of high-speed steel tooling. So carbide tooling is going to, while it's a little bit more brittle, it will stay sharper, or it's going to stay sharp for longer. Okay. It is true that with high-speed steel knives, you can actually sharpen them to create a sharper edge. But for planing, that's not necessarily a big deal to me. Okay. I really like these because, let's say, for example, I want to resharpen my cutter head. I'll just loosen up each one of those little inserts and rotate it 90 degrees. I get four uses out of each one of these carbides before
I have to replace them with new ones, okay, so that's one thing. The other thing, let's say you have somebody, or you have you find a board and stuff about, and you just got to run it through without even really paying much attention. Can't put it on the nail it. With high-speed steel knife like this, you'd have to replace all three of them, or however many knives you have, or send them to Acme and have them resharpened. Okay, with this particular style of cutter head, you might have three, but you know, they're otherwise, does everybody understand when you send a board kind of nail through the planer, what you're gonna have on every other board that you run through after that point is a board that has a little spot in it that doesn't get planed down to the same flat surface, and so that's what we're wanting to use dirty wood. Especially you don't want to use dirty, send a dirty board through a thickness planer that you are unaware. That's why I worry about this when you buy new wood, even from, I've gotten material from Lowe's before, that have staples in it, because they, you know, they're putting paper and they're stapling it to the side, and you're not paying attention, you can create a lot of damage like that, okay? When you're using the planer, you're gonna try, I mean, rule of thumb for me is maximum of 1/16 of an inch per pack, okay? The way most planers are designed, is the motor is sized so that for the width of the table that you've got, if you're planing oak, which is very hard wood, you can remove, a 1/16 of an inch per pack. Okay, if you're planing, softer wood like pine, could you do a little bit more than that without causing damage or overloading the motor? Yeah, probably. But as a general rule, I don't mess with that, okay? Which 1/16 is one full rotation of that table pipe, that adjustment, okay? 1/16 or one full revolution is all you'll want to take off per pass, all right? The other thing too, I don't know if I've got a picture of it, but a lot of planers will have, just kind of a guard. It will prevent you from putting a board that's thicker than 1/16 of an inch from where it's set up. And so that helps as well to kind of control that. The other thing too is you ever want to send a board that's shorter than the distance between your feed rollers. Okay, and that's generally about 10 inches. Okay, depends again on your machine, but the distance between the outfeed roller and the infeed roller is going to be about 10 inches. If you send a board that's 8 inches, it's going to get stuck in between the two rollers, and you won't have anything that can force it through. Okay, and it's going to be just out around in the machine lock quick. Now, one thing I have found is, say for example, you have a board that's 8 inches. What happens if you turn it at an angle and run it this way? Sometimes you can make that work if you're in a pinch. But sometimes when it feeds through, those feed rollers have a tendency to kind of, it doesn't necessarily feed in straight. So there's always a risk with that, okay? But as a general rule, I never send a board that's less than 10 inches through the planer. So what do? You have a situation where your part is 10 inches and you need to plane it down. What do? You put it in the ice and use a hand plane, or you can oftentimes glue them or use two-sided tape and glue them to another board that's maybe a little bit longer. There's some different ways of getting creative that way. The other thing too, watch your fingers. Okay, when that pressure roller grabs that board and starts pulling it in, it wants to snap that down. So don't ever hold your fingers underneath the board and get your fingers pinched that way. Look up into the planer. This is a messy process, you guys. It creates a lot of chips, and so always make sure that your dust collection is turned on, and or do it in a way where area where you have a lot of insulation. It's really messy that way. And then you have snipe. Have you ever heard of snipe? It's not the bird that you go out and hunting at night. No, that's not what I'm talking about. Snipe is what happens when you have a long board. Imagine you have, this is your plane, right? And you have a board that's this long, right? You got a lot of weight hanging down on this end. Actually, this is the end feed, so it's going this way. So it's over here, right?
So by the time you have so much weight, once it gets past that empty roller, the weight of the board causes it to kind of sag. And so what happens is you get a narrower, end of the board. It looks like this. Okay, that's called snide. How do you avoid that? Well, you just put a little bit of pressure up. Help support the board when it's going through the plane, and then you won't have to deal with it. Okay, and so that's what's nice. They talked about how sometimes if the cup isn't so severe, you can get cups out by using a surface planer. The other trick I've found is to take a little thin strip of soap or like a strip of wood. And you can glue it to the bottom or use a piece of two-sided tape that kind of keep that cup from getting pushed out when it goes under the pressure roller. And that will help to support it. You're able to cut off a smooth top surface that's flat. You flip the board over, and now you can get rid of that cup, and it's in this relaxed shape. Okay, so that's a way to use the planer to get it to do essentially what the joint is. Okay. Does that make sense? I'm seeing some people nodding, so that's good. Okay. Also, you have a limit on the thickness of board that you can send through the planer. I've always heard that you don't ever want to send a board that's narrower than, or that's thinner than 3/8 of an inch through the planer. How do you get around that? Well, you can use a backer board. You can glue, or you cannot glue, but you can use two-sided tape and stick a board to a backer board and send it through the planer out. And that is oftentimes a way to get the thickness that you need in order to have, have sufficient room inside the planer to do stuff that's less than 3/8. Okay. Some industrial planers that you might find out there. You have your two-sided planers. Oh, one time I was down buying lumber down at Drakesville. There's some Amish guys down there, and they had one of these big, it was interesting because it was run on gas, right? We started this thing up, they started this thing up and this sucker had a cutter head on the top, had a cutter head on the bottom. And they were taking off, we were starting, I think I ordered like 5/4 lumber, but they didn't have 5/4. And so they were just gonna make the stuff that I think they had some 8/4. I can't remember exactly. Maybe it was only 6/4 I was buying. But anyway, they sent that thing through the double-sided planer and they were taking off like 1/4 inch on both sides. It was amazing, the power that was behind that planer. But again, that's what you can achieve. You can take off that all in one shot using a two-sided planer. And so that's kind of a nice machine that way. You have what are called abrasive planers. And those are just big planers. Instead of using cutter heads that look like this, okay, where you have the cutter head with a high-speed steel or carbide, they use big, wide belts, okay, that have a real coarse abrasive. And some of them, like you can see on this machine, will be a hybrid machine where they have a planer and then they follow it up with wide surfacing belts, okay? And so those are really nice machines. That's going to be one of the next machines I get in our lab is a nice wide abrasive planer. I think they've got one over at Pellet Christian. Do they have one at Pellet too? Yeah, I want to get one. 24 inches wide. Yeah. So, all right. Next machine that we'll talk about. So before I back up, I wanted to show you guys these. These are the little carbide inserts that we use on our planer. And they cost about $20-25 a piece. And so that's why we just have to make sure we take good care of our equipment. But all right, table saws. Table saws are really, for me, kind of a workhorse in the lab. They are such a versatile machine. They're used for cross cutting, for ripping, for cutting dados, for cutting papers, for cutting levels, for doing all kinds of stuff. Okay.
And so they are just an incredible machine. And so, well, let's kind of talk a little bit about, I guess, the parts of the table saw. So you have your, your switch. This particular, hand wheel right here is for elevating the arbor. Okay, so if you're cutting thicker material, you're gonna raise that blade up. Okay, and that, you're just gonna turn this hand wheel right here. The one on the side is for tilting the board. If you wanna do a bevel, or if you're, yeah, that's the main thing. If you're wanting to cut a bevel, you're gonna need to tilt the blade. And some saws are right hand tilt, some saws are left hand tilt. And so if you're ever purchasing a saw, you'll want to pay attention to that. You've got the cabinet. So like there's different types of table saws. You probably have seen them. So the benchtop saws, those are kind of the portable ones. I've got one, and they're nice because you can just throw it in the truck, you can take it to the job site, you can run small trims and stuff like that. And so benchtop saws are really nice. They're not going to have a very large cabinet. They're not going to be very heavy. They're designed for portability. Okay, and so those are kind of nice. I think Andy, you're saying you have a little small table saw. So try one of those benchtop saws out of it. You have what's called your contractor saw. Again, they have pictures of these in the book that I think are really helpful. But these are, my dad had one of these growing up, and it was a saw, and it had a nice heavy cast iron table, but oftentimes the cast iron isn't solid. They're kind of webbed. You can kind of visualize in order to kind of make it lighter. So it has some portability to it. But then you have kind of an open bottom, and the sawdust just kind of falls on the floor. So these particular saws are going to be what are called contractor saws. Your cabinet saws are going to be like this. This is, you've got kind of a solid cabinet, and then you have dust collection that comes out the back so that your dust collector can clean out those chips that way. And so they're really heavy. Oftentimes they have a nice fence, an add-on, or sometimes they're an add-on. This Beechmeyer is the company that makes the really nice fences, and they're just super nice. The fences have really come a long way. Those come out of the kid there. Seems like a lot of the contract or the cabinet saws have a really nice fence nowadays. And it slides back and forth nice, it's very accurate, it walks down really good, and you have a nice what's the material, like a formica or a melamine ripping fence that way. So they're really nice. And the table can rip, they're designed for ripping plywood. And so they can oftentimes you can cut 48-inch wide off to the left side of the blade. So those are really nice saws. And then you have what are called your European or industrial European saws, which are really designed for working with plywood as kind of your main stock material. And they're just a lot bigger. A lot of them will have cross sliding sleds on them, and they can be set up with gang saws where you have multiple saw blades. And so they're just a large industrial machine that are designed for working plywood, because when you're doing European cabinetry, that's your predominant material. You're not cutting as much solid wood, you're cutting up a lot of plywood. And so that's kind of the basics of the saws and the different types of saws. And we kind of talked a little bit about saw blades last week. Remember, saw blades are spec'd by diameter and arbor hole size, okay, and by the number of teeth. You can also buy, and sometimes you can see, you can buy blades that are designed for plastics. And the big difference between plastic blades and, like, say, a trim or a fine tooth saw blade is going to be the hooking. It has to do with the rake angle. Again, there's a difference between ripping blades and cross-cutting blades, and that usually has to do with the depth of the gullet. Okay, ripping blades are going to have a lower number of teeth, deeper gullets that way. And then there's the difference between the cutting material. Is it a high-speed steel cutting edge, or is it a carbide, raised in carbide cutting edge? And so there's just a lot of difference. There's a lot of technology in this blade. They're just not. it seems like you can buy them in different gauge thicknesses, and so there's really kind of a lot there. This is a video that I pulled off the internet. We have saw stops in the lab, okay? You guys know what saw stops are? You've heard about them? They're the ones that, when you cut into a hot dog or your finger, they will have a safety feature built into them to protect your finger that way. You can see that it still gives it a nick, but that's a whole lot better than losing your finger altogether. And what happens is the arbor drops down. You can see underneath the table, there's what's called a cartridge. It's an electronic device. It's got a spring loaded. I'm pointing at that. It's got spring loaded. And so what happens is it pushes it up into the blade. The momentum of the blade stopping is going to drive it down. And so it's a really nice feature. In fact, we're almost to the point. So we've got a lot of teachers that take this class. And so I always mention that safety is something that is interesting. When you see an accident, somebody that gets hurt at work, go into the court because of a lawsuit. In normal law, you're innocent until proven guilty, right? Well, in these liability suits, you're guilty until you prove that you're innocent. Meaning that you have to demonstrate a certain due diligence. You have to demonstrate that, hey, I did this, and it's unfortunate that this accident happened, but you have to do everything you can to make sure that you prevent those accidents, and you have to document that, and you have to protect yourself that way. And it's almost to the point now where it's a liability not to have one of these saws. And so that's why you see a lot of schools that are getting saws, because nobody wants to have a student or somebody who's going, doesn't know how to use a machine, having an accident in their life. Right? So anyway, we've got saw stops, and it's just it's all that they're cracked up to be. I mean, it's a really nice machine. Yeah, you do. Yeah, you do. You have to replace this. It's just there's two pins. You pull that out. It's about $80. And typically the blades are ruined too. So, an accident's going to cost you $150 compared to millions, and so that's worst case scenario. And possibly, some loss of quality of life, or, even worse than that. So, yeah, I think it's worth it. So, but just understand that this is the type of saw that we have. So that also means that we can't cut green wood, okay, without turning that feature off. Okay, we can't cut aluminum. Anything that's conductive is going to set that feature of the saw off. Okay, so even green wood that has lots of moisture content, okay, that's going to set it off. So you have to just run the saw in bypass mode. And there's a trick to doing that. I can show you how to. They're really worth their weight in gold. We actually had a student who needed that. Local student, he was running his board through, got all the way through, and as he was reaching his hand over to grab the next piece, he nicked it with his finger. And I heard it, and bam, the thing happened like that. Moral of the story, don't get into a hurry. Don't reach over the blade. Don't, be aware and be conscious of what you're doing at all times, and make sure you're well rested and you're focused. Okay. My grandpa, or my wife's dad, or grandpa, has a finger that he cut off on the finger. It's easy to do. You're not in the kitchen. And he'd been using it his whole life. So it's not that he didn't know what he was doing. He was just not in the machine, just kind of a finger right into it. So anyway, I'm not trying to tell the horror story. So different types of or I guess specifically for ripping, this is how you do it. You set up your blade height. We always want to set that blade no more than we have to. Okay, I would say about 1/4 of an inch, or if you're using a cross-cutting blade, or if you're using a ripping blade, just if you're using a cross-cutting blade, that's about to the bottom of the gullet, but if you're using a ripping blade, they both tend to be lower, a little bit deeper than that. So just 1/4 inch, set up your fence. Use a push stick if necessary. You can see him using a push stick. I brought a couple of examples of push sticks here. There's different, whatever feels comfortable to you guys. If you're doing long boards, something like this would be a really good push stick. If you've got short boards, you're gonna need to put more pressure on it because if you're pushing that into the board, it's gonna kind of want to lift on the leading edge. And so a push stick like this might be a little bit more better suited for shorter boards. But, you know, never get in with that margin, within that, what did we say, a 4-inch margin of safety? If you're cutting a board that's narrower than 4 inches, and you have to hold it somewhere close within 4 inches, use a push stick. And don't forget to clear the back of the blade. When you're pushing your work through, always push that board beyond the back of the blade. Never want to let go of the board when it's pinched between the blade and the fence. What happens? Well, it'll get a turn, it'll line with the blade, it'll be coming right back at you. Okay, so always push it all the way through. That's a habit that you want to get in. Okay. This is just shows you ripping, cutting, and most of the time this is parallel to the grain, but again, it just kind of depends. But usually it's cutting the boards, you know, get a lot of length, you're going to be ripping that length in half. Cross cutting would be usually cutting up into the, that's kind of a, you know, way to say that. This shows what a resawing operation is. Sometimes you want to cut the board's thickness in half, and that can be done safely on the table saw. You can see that you've got a lot of blades exposed, and this particular operation prohibits the use of any guards, so you do have to be careful. But you can safely do that on the table saw. One of the things that that kind of makes me nervous would be if you were to try to take that off all in one shot, right? Now, obviously, this particular board couldn't do that because it's too wide. And most of the time, most saws will allow you to bring that saw blade up 3 to 4 inches or somewhere in there. And that would be about the maximum you'd be able to, maximum height that you could adjust that. But some boards, I mean, if it was a narrow or a little bit not as wide of a board, you could cut that off all in one piece, but you have to be careful because there's not very much distance between the blade and the fence there. And you would need, it would require you to use a push stick to do that. And so sometimes it just gets kind of tricky. You can always run it in 2 paths, okay? And that's kind of the preferred way to do that, right? And so, and some guys will even say, don't cut them apart on the table saw and then just cut it apart with a handsaw afterwards. But it's kind of up to operator preference. Look at that picture. What's wrong with this picture? There's a couple of problems with this picture. Can you guys identify what they are? Danny? This one right here, it's kind of stuck in between what looks like between the blade and the fence, and that's a no-no. Okay, good. The width of this cut is longer, is wider than the width of the board. Correct. So what Cole is saying is the width of the board right here is less than the length of the cut, right? And so what's going to happen? Why is that a bad thing? It's going to want to get cocked in between the table saw blade and the fence, isn't it? And it's what happens when that happens. Well, it binds up and then it kicks back. So it can, oh, I forgot to mention we're going to do an observation. He's just going to hide in the back and watch you. So, and so that's a bad thing. What else? What else is wrong with this picture? It doesn't have a safety guard on it. Does it have one? Probably would be no, I mean, the operation isn't prohibited, is it? So he probably should have one on. Maybe blade height. Blade height, that's a good one. Yeah, he's got way more than a quarter inch above. This guy's a little. There's more. When you find it. He's got long sleeves with loose cuffs, right? That's something we like to avoid. Probably the biggest one right here that I see is he's doing a cross-cutting operation. And he is feeding that, you see how you've got the fence right there, right up next to it? And then you've got the blade. What happens when he cuts through that board? That board is gonna be pinched between the blade and the fence, and that's no bueno, you can't do that. And even if he has a hand on it, he's pushing it through, again, we go back to Cole, that board's not very wide, it's very easy gonna get popped in between there, and this is gonna cause a problem. What is the right way to do this? If I'm gonna say, I mean, yes, you could use the chop saw, and that's probably a preferred way, but sometimes cutting multiple pieces that are all really short, it's easier to do that on the table saw and more safe because it's really hard to hold the, on the chop saw. The best way to do that is to use a setup like this, where you have a block that you can slide the board over, touch the block, and then and you've got your miter gauge, and you're feeding that in there, because there's a gap at the end of our board now, because the block is set back. Now we've got some space for that board to kind of fall off, and it doesn't matter if it tilts a little bit. And that's how you set that up. And so if I had like 20 short little pieces, that I needed to process, this would be the way I would use it. Okay. But again, this just shows how we can use a miter saw to do cross cutting. You can use a table saw to do beveling by using the blade tilt. There's the wheel on the side. We can do a blade tilt that way. I like how he's got his push stick right there for when you can grab it. Okay. We can use this dado stack to do grooves and dados. So, you guys familiar with dado stack? This is the stack dado set. We don't really use it anymore. So I use this for just kind of visual. So you have kind of your side blade here. You have a left side and you have a right side blade. And then you stack the chipper blade in between. So depending on how thick of or how wide of a groove or how wide of a dado you're wanting to cut, you're just going to stack a bunch of these chipper blades in between. And when you need to adjust it, you can use pieces of shim material to kind of stick those in between the stack, and now you just need the 16th or 64th or 32nd wire. So you can add shims to that. And so that's what a dado stack is. And they also have some different kinds. Some of them have kind of a little wobble on the side where the chipper is just kind of, there's some different styles of dados. This is my favorite. But when you use a dado blade, usually the diameter of these blades are only 8 inches as opposed to the standard 10-inch table saw blade. So and if you're using a saw stop, that means you got to use a different cartridge. Okay. And then you have to also use a different throat plate. And the throat plate is going to look like this. It's just kind of you want to have as little space in between the blade and the table. And so these throat plates can be, you can make them out of wood to make your own, or you can buy them. And so there's just some different, I guess there's a couple of different things that are associated with cutting dados that would have been helpful to know when I'm first starting out. So there's that. And also, notice on this one, when you're cutting a dado, that is one of those processes that's prohibitive. You cannot have the splitter and blade guard in place when you're doing that. So that's why you don't see that blade guard. But that cut doesn't go all the way through. Okay. Some other things, you can do tapers using a taper jig. That's a common style of taper jig. I thought when you're
a couple of years ago from Rockler. Rockler has all sorts of kind of tools, and so this is kind of one that comes with, so this little bit fits in the T slot or the slot on the saw. I've got this backwards. This is the back. You take your board and you kind of hook it right here, and then you have these clamps. And so you can position that board, you know, at any angle that you want using this stuff. So that's kind of another take on taper jigs. A couple of other types of jigs. It's called a box joint jig. Kind of an ingenious thing. If you've never cut box joints before, you can make these. Oftentimes they have certain box joints, and so part of the joy of doing that is designing the jig and making the jig that then you can use to make your parts to create that box joint. Okay. This shows a sharpening machine. They call these, I think, jointing machines, not to get confused with a joiner, but they have a diamond grinding wheel that is designed. It's at the right angle. It can sharpen the blade. Okay. Obviously, we don't have one. Anytime I have a saw blade that needs to get dull, I send a acting tool and then one and they do a really good job. In fact, I've got a box right now. Got like 6 blades, so I need to go 3 sharp. This shows a panel cutting saw. These are really good when dealing with plywood, because plywood is really wide and long and awkward, and oftentimes it's really challenging to get 2 people in sync when you're trying to rip a cross cut, and so sometimes it's just better to cut it on a panel saw. So you can hold the board in place, and then it has this track where you can just bring that saw down and cut through it with plywood. Okay. I guess one thing that you always want to remember when you do this, what side do you want to have the good side of the plywood face? Do you want to face the back or face the? You need to think about. So these saw blades are designed so that the blade is going to be moving like this. Okay. So because that blade is going to enter and come out this way, you want this to be the core face, because that's the face that's going to get out. So the good face you always want facing in the back. So always think about that saw blade. You always want the good side to be the side that the blade leads into. Okay. Just some pictures of some different industrial table saws. And this is a straight line rip saw. Again, this is what they'll have at like a lot of the mills that are doing rough sawn lumber, and customers, when they come like me, they say, I don't have a joiner. I'd like to buy these boards with a straight edge. They just kind of send them through, and it has an automatic feed, and it's going to feed those boards in there in straight line, and that's going to rip a nice straight edge. This is a double-ended sawing machine. This one is this is pretty cool. And we had a couple guys go through fellow windows here in this lab to see if they can do it. They were talking. That's not out there. They were talking about these saws that have sensors on them that detect like bug holes and low density wood and knots, and so it's detecting the defects in the wood, and then it's also cross cutting them to length, and so it has in the computer a certain job. Right, and they need these various lengths of boards, and so it will calculate. It'll detect the defects in the board, and it will figure out the most efficient way to cut on that board, and it happens so fast. It's crazy, and so they get as good a utilization out of that board as anybody can. So that's pretty neat. This is a gang ripping saw, just meaning you have an arbor with multiple saw blades mounted on it, and they're making multiple cuts in one panel. And then you have, hey, there's another video. We'll see if this. We're having a hard time with video today. So this is a big old industrial machine that's designed for cutting the plywood. Get some action. You've got your, throw your sheet on there, and then, again, this is all computer controlled, so it knows where to start. Change the blade. Just move around the saw so that you're on. Pretty cool machine.
Seems like a lot of those industrial plywood machines are coming from Europe. They do a lot of that. Norway. Yeah. All right, last machine that we'll talk about is the bandsaw. We're getting close. I want to try and finish up here soon. The bandsaw, as probably everybody knows, you've got two wheels, one on the top, one on the bottom. Some of them are horizontal, like this one is this is, I think, what do they call it? This is not an Alaskan one, but it's the horizontal sawmill for logs. So yeah, you've got two wheels. This one is a little 9-inch vertical bandsaw, 48-inch vertical bandsaw, okay? And you get that blade running around those two wheels, okay? It's tracking, and so you're able to remove a lot of material really quick. A lot of those blades, I've got some examples under there, I'm not gonna pull them out, but they're really thin. So your earth isn't really that wide, so you get, they really go. So a fantastic machine. We use ours for cutting curves mainly. So when I was teaching middle school, I loved our bandsaw. And I bought one that had that you could run a miter gauge in, and we also came with a whip fence. We were using that for whipping boards, cross-cutting boards, and it was great because the bandsaw, there's no risk of kickback, okay? Because the blade goes cut through the wood in a straight down direction. You've got your table underneath, so there's no forward motion that's going to cause it to kick back, and so it's perfectly safe for kids. I have some yesterday with a presentation 4-H for you showing how to make a big flag and that's cool. Anyway, so here's the parts. You got your wheels up on the top. Usually on these wheels you have what are called, it's like a rubber band or a urethane band that is going to create traction and it's going to protect the blade. Each one of those blades, two teeth, have a little bit of set, so it makes a little bit wider curve during the blade is thick. And so you want to protect the blade from that. So you got to have a good rubber tire on those wheels to do that. You have this knob up here is going to be your tensioning knob. I believe you have a tensioning knob and you have a tracking knob. The tensioning knob is going to stretch that blade so you get proper tension. The tracking knob is going to change on one of the wheels, usually the top. It's going to change kind of the angle of it so that you get that you can adjust the blade so it's right in the middle of the wheel. You want that blade to track right down the middle of that wheel. You've got your upper blade guide assembly. That's what it's called, upper blade guard, upper blade guide. It does two different things. Number one, usually there's a shield that kind of guards the blade and keeps that contained. But the other thing it does is it guides the blade. You have these bushings on the side. Sometimes those are kind of a bronze material. Sometimes they have these little bearings that kind of keep that blade centered and straight. And then you have a thrust bearing on the back that helps to support. So when you're feeding your work into the blade bandsaw, you've got lots of support there. Okay. And so this shows just kind of there's usually a tensioning gauge that'll tell you appropriate tension based on the width of the blade that you're using. Okay. You're going to tighten that tension on until that little indicator points at if you have a 1/4 inch blade, if you have a 3/4 inch blade, you're going to need more tension on that blade. Okay. And so those are kind of knobs. Okay, you've got your throat plates that are interchangeable depending on the size of your blade. The other thing too, we don't really change our blades very much because when you change out a blade, you have to change everything. You have to change the position of your blade guide. You have to change the adjustments of your little side supports, your bushing. Okay, and so there's we typically just run a 1/4 inch blade and you can cut really sharp curves and it's pretty great that way. We do resawing operations with it too. Again, it's not optimal, but we do it. And you get pretty good results that way. Okay. Blades can be bought in different widths, so you can buy a 3/4 or 1/4 inch. You can buy them in different lengths. Sometimes you can even buy a big box, 100 foot, and then you can weld together your own blade. And so, but typically I buy them pre-welded. We've got different thicknesses of blades. We've got different tooth styles, as it shows that. And you can buy your standard blade, or you can buy kind of what's called a skip tooth blade, where they actually have more space in between the teeth that way. And so, never fails though, I always want to make sure we mention the 3-tooth rule. The 3-tooth rule means that depending on the thickness of your material, you always want to have at least 3 teeth of the blade engaged in the material in the front. Does anybody know why that's a thing? Otherwise, you'll strip your teeth off, especially if you're like cutting stainless steel. I had this happen last semester. I had a guy come in with a stainless steel sheet. It's so stiff we couldn't cut it on our metal brake, and so we were going to make it work on a bandsaw. Very careful to just feed it ever so slowly, and you could hear every time. And we really didn't have any options, so I just decided to sacrifice the blade. We were cutting through that, but stainless steel is so hard. If I was to push that in, it would strip all of my teeth off. Okay, so you had to. That's generally not a good thing to do. So, but 3-tooth rule. If you abide by that, then you're not going to need to worry about stripping the teeth off your blade. This just shows how blade width or the tightness of an arc is related to the blade width. So if you have an 1/8 inch blade, you can cut a 3/16 inch blade easy. Not even have to worry about bending the blade or creating what am I trying to say? You create a lot of fatigue stress on the blade if you try to cut a curve that's too sharp with a radius. And so 1/4 inch, we're only able to cut about a 5/8, but that's good enough for what most of the time. Okay, you can use bandsaws for ripping. This one's showing cross cutting. You don't have to worry about kickback. Pretty great. You can do resawing. This is an example. One of the hardest things about resawing is trying to feed that board in. Sometimes if you have a dull blade, the top wants to not cut square. And so you do have to make sure you have a sharp blade. And these resaw pencils are nice because you can kind of steer it. The ability to steer that. And you're just watching the line and watching that blade out there. Okay, one thing I want to mention too is see how this guy has so much material or space? That's no wonder. I like that blade guy to be down, but within like an 1/8 to a 1/4 inch above the top surface of your wood. Okay, so if you guys are ever setting up a bandsaw, make sure that blade guard is down. 2 reasons. Number one, you don't want to have any extra blade exposed, but more importantly, I guess this is me being the Bohemian guy. I don't want to replace the blade any more frequently than I have to. Okay, so keep that support down so that our blades aren't getting worn out prematurely. This just shows some different strategies for making, if you're in a situation where you want to cut a radius that's tighter than what your blade is able to do, you can do what are called creating relief cuts. I've got a couple of visuals that way. Again, this is an exaggeration, but relief cuts are just, we're going to cut, and then as you go and make that cut, those pieces are going to fall away and allow you to change. Now, obviously, those curves are so big it won't necessarily justify the need for that. But then this is the other one, is to cut beyond, back up, and then just, those are called creating canopy cuts, and that's another way to create enough space in order for you to be able to cut that radius without twisting your blade. You can do nibble cuts like what this guy is doing. Okay. Pad sawing is a thing, especially if you have, I think there's a couple of people that are doing this where they have 3 or 4 parts and they all need to be exactly the same. So you use either 2-sided tape, or sometimes you can screw them if you screw the scrap of the board, to put them all together, and you're able to cut those all out at the same time. So that's kind of a nice strategy. to kind of speed up production, but then also allow you to cut out multiple boards so that they're the same thing. Last thing is bandsaws are incredibly helpful when trying to prepare for, like, say, a carving, and you need to do what's called compound sawing. And so here's a quick video. So. I think I have it in the file. Yeah, let's see one that's on the internet. Well, we're out of time anyway. I guess last minute. Let's see what happens. Anyway, not important. Compound sawing, what it means is you're gonna cut it from the top, and you're kind of take the pieces together, rotate it, and then cut it again from the side. And then what you'll end up with is a three-dimensional part. You can take it and start carving or whatever. And so, it's kind of a nice, trick that way, so. All right. That's all I have for you today. I think what we'll do next is go ahead and we're gonna transition to the lab now. You guys have any questions before we go?